Hey guys, I hope everything's going well. Hopefully this doesn't freak you out. I'm going to turn this. This is your study guide for your final. My baby's hiccuping behind me. You might be able to hear it. So what's going on is we're going to talk about the different problems that are on the test. I think this study guide does a pretty good job. First problem here, it says list the first 5 terms. That's what the first thing on your test is going to be. Plug in 1, 2, 3, 4, 5. Number 2 here. Same sort of thing. You plug in 1, 2, 3, 4, 5, and then you plot it. It's the same idea. You aren't going to have to graph it, but you are going to have to add all of the numbers together. I'll give you guys a calculator, so it shouldn't be too bad. It's going to be a basic calculator. Actually, I'd probably give you guys any calculator, and it would work just fine. And that's it. For this part right here, match the sequence with its given nth term. Plug in 1, 2, 3, 4, 5. Once again, plot it. Find the sum. This is the next thing. This is a geometric series. It converges because 2 over 3 is less than 1. And because of that, we're able to go through and find what it converges to. And so you're going to write it as a over 1 minus r. And then you're going to solve for it. I'm going to go up here and turn off the solution so you guys can't see it as we're going through it. Let's go ahead and see this refresh. I couldn't download it for some reason. I have no idea why. I have to do it on my computer. Determine the convergence or divergence of the series. This is one of those problems where you have to go through and you have to think about it. You are going to have an integral test problem. It's not going to be as bad as this one. It should be more of a straightforward one. This is ln of... Is it ln of n? No, it's n over ln of n. This is one where we're going to have to figure out how to go about it. I'm going to leave that one to you guys. The very beginning of this is from 8.2. So that means this is either integral test or a geometric, or it's going to be something that we can use. It doesn't have to be a comparison test. The next one, we have a geometric again. The next one, confirm that the integral test can be applied. Then use the integral test to determine the convergence. First off, we know that this is going to be positive. We know it's going to be decreasing and continuous from 1 to infinity. So we're able to take the integral of it. We know the derivative of 3n plus 9 is going to be 3. So let's go ahead and do this one. Let me go ahead. I'm going to have to go back and forth and back and forth. Let me open up a new window for it. So we have the sum from n equals 1 to infinity of... in this instance, we had 2 over 3n plus 9, 2 over 3n plus 9. And what we know is that this is going to be positive, decreasing, and continuous. And as a result, we're able to go through and take the integral from 1 to infinity of 2 over 3n plus 9 dn. And if this converges, then our sum converges. If this diverges, then our sum diverges. What we want to have is we want to have u prime over u. So we're going to rewrite this as the limit as n approaches infinity. That should be an I of 2. We're going to take this 2 out to the front. And then we're going to have times the integral from 1. Let's call this b of 1 over 3n plus 9 dn. And what we need is we need to put a 3 in the numerator because the derivative of 3n is 3, and then a 1/3 outside of it. Okay. As a result, we're going to have the limit as b approaches infinity of 2/3 ln of 3n plus 9. Okay. Evaluated from 1 to infinity, or 1 to b. Okay. Now what do you do here? You plug in infinity. We're going to get out 2/3 ln of infinity minus 2/3 ln of 3 plus 9, 12. As a result, we're going to get infinity, which means that both diverge. And that's it. That is the integral test. Okay. As for the next one, as you guys are looking at it, confirm the integral test. It's the same thing. Some of these you have to rewrite. I would rewrite this as 1 over e to the power of n because of the negative. Okay. Confirm the integral test, another integral test, confirm the integral test. There's only one integral test on this assessment, but there's one at the very end you can also do the integral test on. Determine when the p-series converges. P-series converges when p is greater than 1. Use the comparison test. This is a good one to work through. 1 over 7 to the power of 8. This is the sum from n equals 1 to infinity of 1 over n to the 7/8 minus 1. Okay, we're going to compare this to, 1 over n to the 7/8, which is a p-series that diverges. Since p is less than 1 is less than 0. It's between 0 and 1. Okay. And so let's go through and determine if it follows this. 0 is less than a sub n is less than b sub n or equal to it. 1 over 7/8 if it diverges. We want anything that's larger than it also to diverge. So this is 1 over n to the 7/8 is less than 1 over n to the 7/8 minus 1. If this is true, then what we know is both diverge. If it's false, then we have to go and try another test or do something different or compare it to something different. If we think about it, the denominator here is always going to be a larger number. It's going to be a smaller number. Why am I messing up on this? If we plug in, say, something like 1 or 2, this is going to have to go from 2 to infinity. I wonder if it said 2 to infinity, because if we plug in 1 here, we're going to get 0 in the denominator. If we plug in 2, we're going to get 1 over 2 to the 7/8. Over here, we're going to get 1 over 2 to the 7/8 minus 1. So the denominator here is going to be smaller, which means this is going to be a larger number all the time. Okay, so this is always going to be larger, so that is true, which means that both series diverge. I'm going to do a few more. I'm going to watch a movie with my wife in just a moment. So let's go over to this next part. Let's go look through a few more. Direct comparison test, I would take 8 to the power of n over 9 to the power of n, and it would make a geometric series when I rewrite it. Same thing on this one. This is a very good problem because there's one of them on your test. It's going to be like number 11, 12, or 13. Those ones you're able to pick 2 to do. You don't have to do all 4 of them. This comparison test, you take all of the exponents. The limit comparison test, what you do is you pick something you know. I would compare this to 1 over n to the 9th. And then because there's an n to the 8th and an n, if you multiply them, you get n to the 9th. So I compare it to 1 over n to the 9th, and then you multiply by the reciprocal. This is going to be a alternating series. So you have to show that the limit as n approaches infinity, approaches 0, that it's decreasing. And as a result, it converges or diverges. Okay. All right. Determine the convergence or divergence of the series. This is the same sort of thing. This is alternating series test. The next one, same sort of thing. You're able to go through and apply it again. Right here's the ratio test with n factorial. This is a good one. It's the last one I'll do with you guys. So let's go through and try it out. So we have the sum. It's number 20. The sum from n equals 1 to infinity of, what was it, 7 over n factorial. 7 over n factorial. It's on Prime Video. It's called Battle Royale. And so from this, what's going to end up happening is we're going to go through and apply the ratio test. In the ratio test, what you do is you guys have to go through, I could show you the rule directly from this. In the ratio test, we only have a few things that we need to look for as we're doing this. It should be one of the last ones here so I can tell you guys the actual rule for it. Okay, so the ratio test you take and you plug in n plus 1, and then if you get a number that is equal to 1, it tells you nothing. If it's less than 1, it converges. If it's greater than 1, it diverges. Okay, so what we do with this is we plug in a sub n plus 1. So to do that, we take the limit as n approaches infinity of a sub n plus 1 over a sub n, and you take the absolute value of this. And we want to show that it's less than 1 for it to converge. If it's less than 1, it converges. If it's greater than 1, it diverges. If If it's equal to 1, it's inconclusive. Okay, so what we do here is we take the limit as n approaches infinity of 7 over n plus 1 factorial over 7 over n factorial. What you do here is you have to go through and multiply by the reciprocal of the denominator. We get 7 over n factorial, n plus 1 factorial, times n factorial over 7. These are both 7s. Our 7s cancel. And then we're going to have to rewrite the denominator. Okay. We know that n factorial is 1 times 2 times 3 all the way to n. And then n plus 1 factorial is this entire thing times n plus 1. That would be the next term in the sequence. So we're able to rewrite n plus 1 factorial as this entire thing. So we have n factorial over n factorial times n plus 1. And that is what we got right here. What does this do? Well, our n factorials cancel, and then we're going to take the limit as n approaches infinity of 1 over n plus 1, which is equal to 0, which means that it converges. And that's it. Okay, converges by the ratio test. Okay, that's it, guys. I hope you guys have a great day. I will see you tomorrow morning.